Good afternoon, this is Mr. Hunter. Not sure why I said that, that's obvious. Okay, we are going to do selected problems from section 17 and 19, maybe curve sketching, not sure how long we'll do. So, first, number 3. On this section, 1 through 4, we are asked to figure out the velocity and acceleration when it's speeding up and slowing down, and we're also going to figure out when it's moving to the left and when it's moving to the right. So first, let's find a velocity equation. This is going to be negative 3t squared plus 18t minus 24. I need to find my critical time now so I can differentiate between when it's positive and negative. So I'm going to set this equal to 0 to get my critical time. I'm going to factor out a negative 3 and t squared minus 6t plus 8. Then negative 3 still there. Then t minus 4t minus 2. Yeah. So those are critical times of t equaling 2 and 4. Let's start a number line. Since we're in particle motion here, the beginning of our number line is at time 0. This number line is representing time. I'm going to plot 2 and then 4. Above the number line, we'll put information about velocity. Below the number line, we'll put information about acceleration. Our velocity, we already found, is 0 at both of those times. When time is less than 2, we have to plug in 1. 1 minus 2, negative. 1 minus 4, negative. Negative times negative times a negative. It's going to be negative. If we plug in a number between 2 and 4, such as 3, 3 minus 2 is positive. 3 minus 4 is negative. And then times that negative. So we'd have negative times negative times positive, which is going to give us positive. A number after 4, such as 5, 5 minus 4 positive, 5 minus 2 positive, but then times the negative 3. Negative out that way. Meaning, in this section of the graph, we're going to the left. Then we're going right between 2 and 4 seconds. Then after 4 seconds, it starts going to the left again. Now let's do acceleration info. Our acceleration equation, I'm going to take the derivative of our first velocity equation, which is going to give me a negative 6t plus 18. And we need the critical value for acceleration. So when does that equal 0? That will equal 0 when t is 3. Subtract 18, divide by negative 6. And you get t is 3. So now we'll add t equaling 3 to the number line. And at t equals 3, we know that acceleration is 0. Now we need to what's happening before and after that. Well, if I was to plug 1 into this, 1 times negative 6 is negative 6 plus 18, positive. So we're positive before. After 3, if we plug in 4, that's going to be negative. Okay, so when are we speeding up and slowing down? We are speeding up anytime velocity and acceleration have the same sign. Anytime velocity and acceleration have the same sign. And we are slowing down anytime they have different signs. So as we move across, we see that between 0 and 2 they have opposite signs. But then between 2 and 3 they're both positive. As we continue moving across the graph, between 3 and 4 they have opposite signs, but then after 4 they're both negative. So it's speeding up in the right direction between 2 and 3, and then it's speeding up in the left direction after 4. Slowing down. That's slowing down anytime they have different signs between 0 and 2. Union 3 to 4. Okay, and that's problem 3. And yeah, that's it. Now going on to the next page. Next section, I'm going to do problems 7, 9, and 11. So if you have not done 7, 9, or 11, you could just pay attention right now. You want to put it up on the projector?
Is this on which one?
Page 100.
Oh, it's on that, right?
So, problem 7. On problem 7, we're told a diver is diving on a diving board 12 meters above the water. He dives vertically from the board with an initial velocity of 4.9 meters per second. Okay, so if I made a little picture for what's happening, we got this diving board. We got the water down here. The diver diving like that. Oh, you can't see that. There we go. Okay. His initial position is the 12 meters. S sub 0 equals 12. We are told the initial velocity is 4.9. So V sub 0, 4.9. We know from our notes, and anytime you're doing these kind of problems, I'll also give it to you. Our projectile motion equation for meters is negative 4.9 t squared plus v naught t plus s naught. And we know v naught and s naught, which is nice. So we have the actual equation. Part A asks, how high will the diver get above the water? So we want this y value. We want the position when he reaches his maximum. We want the position when he reaches his maximum. Well, in order to get the position when he reaches the maximum, we need to know the time that he reaches the maximum. Well, the time he reaches the maximum, his velocity is going to be 0 up there. We were going up, then we switched direction to going down. So his velocity at that moment was 0. So we need the velocity equation. Our velocity equation is going to be negative 9.8 t plus v naught, and we know that's 4.9, so plus 4.9. So again, we want the y value when he hits the maximum. So in order to figure out that, we need to first get the time at which he hits the maximum, and the time he hits the maximum is the time at which the velocity is 0. So 0 equals negative 9.8 t plus 4.9. Move that over, negative 4.9 equals negative 9.8 t divided by negative 9.8, and t will equal, using my calculator because you're allowed to do that on this section, negative 4.9 divided by negative 9.8, and we get 0.5, so t 0.5 seconds. You know, that should have been obvious. 4.9 is half of 9.8. Okay, this isn't the final answer for this part. This is the time at which he hits his maximum. We now need to know the actual position of the maximum. So we're going to take that time and we're going to plug it into the position equation. Our position equation, we need the position at when the time is 0.5. That should be a 5. So S of 0.5 equals negative 4.9 times 0.5 squared plus our V naught is 4.9, so plus 4.9 times 0.5 plus S naught is 12. Now, why would you just put that in the calculator? So the position at 0.5 equals, and I'll put that in the calculator, and we get negative 4.9 times 0.5 squared plus 4.9 times 0.5 plus 12. 13.225. Okay, part B asks, how long will it take the diver to hit the water? Well, water, we're considering position 0. Water's the bottom, position 0. So we want to know when his position equals 0. So we're going to take our position equation, S of t, which is negative 4.9 t squared, plus v naught, no, not v naught, let's use our velocity, 4.9 plus 4.9 t plus 12, and we're going to set our position equation equal to 0. And we want to solve for when we need to know the time, how long. Long refers how long does something take, refers to time. We want to know the time at which we hit our position of being 0. So now we just need to figure out when this equals 0. Well, luckily we can use a calculator. And so in my calculator, we're going to put this equation in y1. If mine looks weird, it's because I have an 89. So we have negative 4.9 x squared plus 4.9 x plus 12. We don't know when that equals 0. So now, next we're going to go to our graph. Okay, that's your window probably looks weird. This just shows up because this is the last window set from the last time I used the graph. But it is helpful to zoom in near where it equals 0. Okay, next, no matter what kind of calculator you have, if in the 84 or 83 it'll be second calc. For me it's this math section, but you want to find the 0. You want to find 0. So for you, second calc 0, 2. You get on the left side of it, and you get on the right side of it, then it tells you. Oops, I went away. Didn't want to do that. Okay, there we go. 2.143. Okay, there we go. Now number 9. Number 9, a man drops flotation device from a bridge. If we were just dropping something, that means v of 0 equals 0. No velocity if we just drop it. Okay. S of t, are we in feet or... let's work in feet then. Let's work in feet. Well, the feet equation is negative 16 t squared plus v naught t plus s naught. And right now, v naught is 0. So s of t is going to equal negative 16 t squared plus s naught. We are asked, how high is the bridge if the device hits the water 4 seconds later? Well, when it hits the water, that position would be 0. So we know S of t is going to be 0. So when S of t, the position is 0, how long did it take for the position to end up equaling 0? It took 4 seconds. So I'm going to plug 4 in there. Now just solve for the initial position. We're solving for the initial position because the initial position is where he dropped it. Well, where he dropped it is at the top of the bridge, and that's what we're asked to find, how high the bridge is. Okay, so now 0 equals 4 squared 16, 16 to the negative 16, negative 256 plus s naught. Put that to the other side. 256 feet is our initial position. on B, we're asked what is the speed of the device when it impacts the water. Well, so we're going to need to use a velocity equation now. Well, we know from this that our actual position equation, ignore that, that should not, S of t is negative 16 t squared plus 256. Well, if that is our position equation, we're also going to use the velocity equation. Velocity is going to be negative 32 t. If you take the derivative of 256, that's just 0. So that's our velocity equation. One problem, we currently don't know the time, so we need to figure out the time when it hits the water. Oh wait, we already know that. 4 seconds. Duh. So, plug in 4. So then V of 4. Negative 32 times 4. Negative 128 is the velocity. But then that means that the speed being absolute value of velocity is just 120. Well, that's annoying. Thank you, Ryan. Velocity turns off, these lights turn off annoyingly. So our speed ends up being 128 feet per second. Okay, next problem, number 11.
I have to go soon.
Okay, bye.
Posting this on the
Yeah. 11, similar to problems we've already done, 7 and 9. Projectile fired vertically with an initial velocity of 96 feet per second. So, V sub 0 equals 96 feet per second. From a tower that's 256 high, so that is S sub 0. Okay, now to make our position equation then, we have S of t equals negative 16 t squared plus 96 t plus 256. Per A, that's how long will it take for it to reach its maximum height. Okay, so that means we want the x value, the t value, of when we hit the maximum. Well, at the maximum, velocity would be 0. The maximum velocity is 0. So we just want to know what time is the velocity 0. So let's get the velocity equation. And then set it equal to 0. So negative 32t plus 96. And set that equal to 0. Negative 32t equals negative 96 divided by negative 32. And the time is 3. Yeah. At 3 seconds, it hits its maximum. Then what is that maximum height? Now we take that 3 seconds and plug it into the position. We want the position when we're at 3 seconds, because when we're at 3 seconds, it's at its maximum height. So S of 3, negative 16 times 3 squared plus 96 times 3 plus 256. So S of 3. Now I'm just going to put that in the calculator. Negative 16 times 3 squared plus 96 times 3 plus 256. I get 400. So 400 feet is its maximum height. Part C asks how long will it take for it to hit the ground. So we're asked the time at when it hits the ground again. So the time at when the position is 0. So we're going to take our position equation, S of t equaling negative 16 t squared plus 96 t plus 256, and set that equal to 0. One really nice thing about this, though, is we can factor this. So I'm going to factor out a negative 16. And I'm left with t squared. 96 minus 6 divided by 16 is 6. That should be negative now. Negative 6t pulling 16 out. Yeah, that's 6. Then that's going to be minus 16. Yeah. Okay, yeah, duh. Okay, so then we get t is a minus 8 and t plus 2 equals 0. Meaning at t equals negative 2 and positive 8. But those do we have negative time? No, so it's just at time equals 8 seconds. And that's what's the speed when it hits the ground. So now we just need to take our 8 seconds, plug it into our velocity equation. V of t, remember, is negative 32 t plus 96. We specifically want the velocity when the time is 8, because the velocity when it hits the ground, we know it took 8 seconds to hit the ground. At 8 seconds we hit the ground. So V of 8 is negative 32 times 8 plus 96. Which is negative 160 feet per second. But they said speed, so that's the value, so speed is 160 feet per second. Okay, so that's all the particle motion stuff. Function analysis section. On this first part of function analysis, we will be looking at intervals of increasing, decreasing, relative extreme. In order to find any of those things, we need to first find critical values of the first derivative. I'm going to do 3 and 4. So f prime of x and 10x to the 4th minus 20x cubed minus 240x squared. We know when does that equal 0. Okay, I'm going to pull 10x squared out of everything. I'm going to pull 10x squared out of that. I'm just left with x squared. Pull 10x squared out of that. That's going to be left with a minus 2x minus 24. Okay, then that's x. Minus 6x plus 4. Okay, so our critical values when x equals 0, 6, and negative 4. Okay, now we're going to make a number line. Put an f prime intro above, it's 0 at those spots. If I plug in like negative 5 squared, okay, so it's going to be positive out that way. Negative 5 minus 6 would then be still negative. Negative 5 plus 4, still negative. Negative times negative, positive. So we're positive over there. Or if I plug in negative 1, negative 1 plus 4 would be positive. Negative 1 minus 6, negative. Okay, so this is going to be negative in that section. We put in a positive 1. Positive 1 plus 4 is positive. Positive 1 minus 6, negative. That'd be positive. Okay. Then after 6, everything will be positive. Okay, So now we're going to stay when we're increasing, decreasing, and what the relative extrema are. Increasing. We're increasing from negative infinity to negative 4, and from 6 to infinity. We're decreasing from negative 4 to 6. Okay, anywhere f prime changes from positive to negative or negative to positive, where f prime changes sign is going to be a relative extrema. Notice over here, f prime is positive, meaning we're increasing. So it was going up, and then it changes to going down. So that is a maximum. We have a relative max at x equals negative 4. We have a relative min. See, over here we were decreasing, then it switched to going to increasing. So we have a relative minimum at x equals 6. Okay, number 4. On number 4, we have to do a product rule. F prime of x. Root of the first is 1 times that square root. So x plus 3. And then plus that x times derivative of this. When we take derivative of this, we're going to have a 1/2 times x plus 3 to the negative 1/2. X plus 3 to the negative 1/2. Negative is going to put it in the denominator. 1/2 is going to make it a square root of x plus 3 times the derivative of the inside. The derivative of the inside of that is just 1. So this is what we have right here. You can ignore it. Write it like that. There we go. Okay, we want to know when this equals 0. Now, we also want to know when this is undefined. To do those, I'm going to get a common denominator. To get a common denominator, I'm going to multiply this first term by 2 square root of x plus 3 over 2 square root of x plus 3. When I multiply this first term by 2 square root of x plus 3, square root of x plus 3 times square root of x plus 3 just becomes x plus 3. The square roots go away. Then we have that plus x over there. Now it has a common denominator of 2 square root of x plus 3, which is 2x plus 6 plus another x. So we have 3x plus 6 over 2 square root of x plus 3. I want to know when this is 0 and when this is undefined. Well, that denominator will equal 0 anytime x is negative 3. So critical values. Negative 3 is a critical value, and this will equal 0. If I subtract 16 divided by 3, that will equal 0 at negative 2. So negative 2 is also a critical value. Now, we're going to make a number line. One thing slightly different about this number line than other number lines is that in our original function, we cannot take the square root of a negative. You can't take the square root of a negative. So the smallest thing the original function ever is negative 3. So negative 3 could be considered the end. If I plug in anything less than negative 3 into this, nothing's going to happen. It won't produce anything. Because if we have negative 4 right there, negative 4 plus 3 is negative 1. Square root of negative 1, nothing happens. It does not exist. We're not dealing with complex numbers. So negative 3 is the lowest it even can be. And our derivative at negative 3 was undefined. So we're going to write info about f prime right above and f prime ends up being undefined at -3. Our other special points, -2, -2, 0, between -2 and -3. Well, if I was to put in -2.5, -2.5, -2.5 plus 6 would be negative. Yeah. So we're negative in that section. And it's going to be positive afterwards. So we are going to be increasing between -3 to -2. I'm going to put a hard bracket on that though, because at -3 it is like solidly -3. There's not even like left of it. And we are decreasing. Oh, I had that backwards. We'll just switch those around. That is decreasing. Then we are increasing from -2 on to infinity. And we were decreasing, then we became increasing, so we have a relative minimum at x equals -2. Okay, going on. I'm going to do 7, 10, 12. Hopefully we'll move a little quicker. This is taking a while. F prime of x. Doing the same stuff on this problem. Derivative of 2 sine is going to be 2 cosine of x. Then plus 2 is going to come down front, 2 cosine of x, and times the root of cosine, which is a negative sine of x. I'm going to factor out 2 cosine of x. Factor out 1 minus sine of x. We'll know whenever that equals 0. Okay, this will equal 0 whenever cosine equals 0. Cosine equals 0 whenever x is at pi over 2 or 3 pi over 2. This will equal 0 whenever sine is 1. Well, sine is 1 at both of those spots. Okay, so those are the only critical values. Now to make the number line. We are constrained to an interval here from 0 to 2 pi. 0, 2 pi, pi over 2, 3 pi over 2. F prime information right above. So F prime is 0 at both of those spots. Less than. And let's just look at this. If we were to plug in pi over 4, cosine of pi over 4 is positive. Sine of pi over 4 is positive. And it's less than 1. So 1 minus that, positive. So it's still going to be positive. Positive times positive, positive. Between pi over 2 and 3 pi over 2. Well, I could pick pi. If I picked pi, cosine of pi is -1. So I've got a -2 out here. sine of pi is 0. 1 minus 0 is 1. So it's negative in the middle there. And then afterwards, if I picked like 7 pi over 4, or 7 pi over 4, which is like right there, cosine would be positive. Right? Yeah, cosine positive. And sine is, well, sine would be negative, but you'd have 1 minus a negative, so you'd end up adding. So positive times positive, positive, yeah. Okay, so we went from increasing to then decreasing. So that was to a maximum. So we have a relative max at x equals pi over 2. We have a relative min at x equals 3 pi over 2, because we did go from decreasing to increasing. We didn't write increasing and decreasing, so we are increasing from 0 to pi over 2 union 3 pi over 2 to 2 pi. And then we're decreasing from pi over 2 to 3 pi over 2. Okay, 10 and 12. Okay, now we are looking at concavity. So we're going to look intervals concave up, concave down. It's concave up when f double prime of x is positive. It's concave down when f double prime of x is negative. And this didn't even really ask for points of inflection, but I'm going to say that as well. So f prime of x here is 8x cubed minus 24x. Then f double prime of x is 24x squared minus 24. We know when that equals 0. Well, if I factor out 24, look with x squared minus 1. So that will equal 0 at x equaling 1 or negative 1. So those are critical values of the second derivative, and they may be points of inflection. 1, negative 1. And more f double prime info. Double prime 0 at both of those spots. If I plug in negative 2 into f double prime, negative 2, you'd have 4 times 24, then minus 24. So that's going to be positive. If we put in something between, so 0, that would end up being negative. The number after 1 would be positive. So we are concave up from negative infinity to negative 1, union 1 to infinity, concave down from negative 1 to 1. And both of these are points of inflection. Number 12. F prime of x. Low. X squared times 0 to the top. 0 to the top is a 1. Minus top x plus 2. So low d high minus high d low. Derivative of the bottom is going to be a 1/2 x to the negative 1/2 all over the bottom squared, which is just x. Now to simplify this, before taking the second derivative, this is x to the 1/2 over x. And when you have exponential terms divided, the exponents subtract. And 1/2 minus 1 is a negative 1/2. So over here we just end up with 1 over square root of x. Then we have minus over here. That x, is in the denominator, but so is 2 square root of x. We just have that x plus 2 in the numerator. Okay. I'm going to get a common denominator real quick by multiplying this by 2x over 2x. So this ends up being 2x minus x plus 2. Minus x is just x. So we end up with x plus 2 over 2x square root of x. So that's our first derivative. Now our second derivative. To find the second derivative, I'm going to call this bottom. This is x to the first power times x to the 1/2. When you multiply exponential terms, the exponents add. So you'd have 1 plus 1/2, which is 3/2. So this is 2 times x to the 3/2 power. Now to take the derivative of that. That's double prime of x. Low is if you can't tell, I get annoyed at that all the time. 2x to the 3 halves. Times to the top. To the top is just 1. Low d high. Minus high x plus 2 d low. To the bottom. 3 halves times 2 is just 3. 3x to the 3 halves minus 1 is just 1/2. All over the bottom squared, meaning 2x to the 3 halves squared. Okay, so we have x 2x to the 3 halves x square root of x cubed minus 3 square root of x, x plus 2 over, when you square x to the 3 halves, those get multiplied. So it just becomes 2x cubed. So now we want to know, when is this 0 or when is this undefined? I apologize, I did not do that problem the easiest way, so I'm going to start it over a much easier way by splitting it up to x over square root of x plus 2 over square root of x, which is x to the 1/2 plus 2x to the negative 1/2. Then to take the derivative of that, f prime of x will be 1/2 x to the negative 1/2 minus negative 1/2 times 2, just a negative 1 x to the negative 3/2. Then the derivative of that, negative 1/2 times 1/2 is just a negative 1, so we're going to have negative x to the negative 3/2 plus 3/2 x to the negative 5/2, which, now to simplify it, is negative 1 over x to the 3/2 plus 3 over 2 x to the 5/2, which we want a common denominator. So to get a common denominator, I'm going to multiply this fraction by 2x. Yeah, by 2x on top and bottom. 2x, 2x. The reason I do that, now this will also have a 2, as well as x to the power of 1. When you multiply exponential terms, the exponents add, so this will become to the 5/2. So this is going to be negative 2x plus 3 over 2x to the 5/2 power. So that is our second derivative. And we want to know, when is this second derivative either 0 or undefined? Well, it is undefined when x equals 0. So we have a critical value when x equals 0. And it is undefined when x is so I made a mistake over here. Negative 1/2 times 1/2 should have given us a 1/4 right there. Which would have meant we would have had a 4 right there. So we did not need to multiply this fraction by 2. We need to multiply this one over here by 2 over 2. To give us a denominator of 4x to the 5/2 and a numerator of, we've got a negative x plus 6. Our other critical value is just at 6. So 0 and 6. Now, we know f prime is 0 at 0 and, no, f prime at 0 is actually undefined. And to the left of 0, I can't put anything negative in because then that's just not going to work. Between 0 and 6, if I plugged in 1, Well, that'd be 1, and that would be positive. So it is going to be positive. And then looking at this, at the second derivative, when we plug in 1, yeah, that would be positive, negative 1 plus 6, positive 5. When we plug in a number after 6, like a positive 7, that would end up being negative. So we're concave down from 6 to infinity. We're concave up from 0 to 6. And that problem took me way longer than it should have. Now, moving on to the next page. We struggle at trigonometries, so I figured I should do one of those. 13. F prime would be cosine of x, derivative of cosine negative sine, but then that negative, so we have plus sine of x. Then f double prime of x is going to be negative sine of x plus cosine x. We want to know when that equals 0, so that'll be when cosine of x equals sine of x. That happens on this interval at x equals pi over 4 and at 5 pi over 4. Now to make the number line, we do a beginning and ending here at 0 and at 2 pi. We're dealing with pi over 4 and 5 pi over 4. So f prime is 0 at, double prime. F double prime is 0 at both of those spots, because we're trying to figure out concavity here. So we need f double prime. And looking at f double prime before pi over 4, well, cosine and sine are both positive there. But if I put a negative on the sign, then okay, we could pick like pi over 6. Sine of pi over 6 is 1/2. So we have a negative 1/2 and then a positive square root of 3 over 2, which is going to be positive because square root of 3 over 2 is bigger. And between here, we could use a lot of different numbers. We tried pi over 2. Sine of pi over 2 is positive 1, but then it would become a negative 1. And then cosine of pi over 2 is 0, so we're negative there. Then after 5 pi over 4, I could pick a 3 pi over 2. Well, 3 pi over 2, sine is negative 1, but then times that negative is positive. Okay, so we're concave up from 0 to pi over 4, and from 5 pi over 4 to 2 pi. and we're concave down for pi over 4 to 5 pi over 4, which means that both of these are also points of inflection. Okay, 15 and 17. Second derivative test. To do the second derivative test, we need to use critical values of the first derivative and plug them into the second derivative. So we're going to find the first derivative. 3x squared minus 4x plus 1. We're going to find its critical values. That have to be 1 and 1. Wait, make that a minus as well. And that becomes 3x squared. That becomes a minus 3x and a minus 1x. That becomes plus 1. Okay, yeah, there we go. So our critical values are when x equals 1 or 1/3. Okay. Next, we take our critical value and we plug them into the second derivative. So we don't have to do a number line. So our second derivative is going to be 6x minus 4. So f double prime of 1. 6 times 1 minus 4 is a positive 2. So, since f double prime is positive, that means we're concave up, so it must have been a minimum. So we have a relative min at x equals 1. And then f double prime of 1/3. Okay, 1/3 of 6 is 2. 2 minus 4 is negative 2. For negative, that means we're concave down, so it must be a max. So it would be a relative max at x equals 1/3. That's all we have to do in these kind of problems. Take the first derivative, find its critical values. Take the second derivative, plug the critical values into the second derivative. That tells you where you have relative max or min based on its concavity. If f double prime equaled 0, then we would say the test fails and is inconclusive. I'm just going to do one more because it's almost been an hour. F prime of x, low, d high, u to the x, minus high, to the bottom is just x, over x squared. We want to know, so e to the x, x minus 1, x squared. Okay, so these critical values are when this is either 0 or undefined. Well, e to the x is never 0, but this could be 0 when x is 1, so critical value when x equals 1, and this whole thing is undefined when x equals 0. Okay, now we're going to take the critical values and plug them into the second derivative. F double prime. Well, okay. When I do this one, low is x squared times zero to the top. Zero to the top. Well, the derivative of x e to the x. Well, I've got to do product rule on that. Oh wait, you know, let's do this factor version. A little less work. So derivative of the top is just going to be product rule overall. For e to the x is e to the x times x minus 1, get rid of the first times the second, plus the first times rid of the second. Rid of this is just it. I mean, it's just 1. So that's low. This whole thing is derivative of the top. Then minus low d high minus high e to the x times x minus 1. Where the bottom is 2x over the bottom square becomes x to the 4th. Wow. Then f double prime of 0 is still going to be undefined. So incon inclusive. That's not going to tell us anything. F double prime of 1. Well, 1 minus 1 is 0, so that term goes away. E to the 1 is E. 1 squared, 1. So we'd have E. Then over here, with 1 right there, oh, that'd just be 0. 1 to the 4th. Okay, so f double prime of 1 is E, which is a positive number, so we are concave up. And so it will be a minimum. We have a relative minimum at x equals 1. Okay, I'm sorry it was that long, but you saw a lot of problems. Hopefully this helped. Have a great weekend.